In this video, I am going to illustrate the concept of a scalar multiple in as much detail geometrically as possible, so to speak. So imagine the following. You are given a coordinate system as the one, kind of like the one I've just drawn here. Okay, so a little coordinate system. This is your y, this is your x. And then you are told you have a vector v, and the components of this vector are 2, 3. Actually, you know what? Let me rewrite that so that it's color-coded, okay? Let's try that again. Let's do it this way. Okay, our vector will look like this. An x component of 2 and a y component of 3, okay? So this is our vector. It's been color-coded, so we can visualize things more easily. So let's mark the x component. An x component of 2 indicates the following. 1, 2. So you draw an x component of 2 beginning from the origin, an arrow of length 2, like this. Okay, that's our x component of 2. A y component of 3 means you draw an arrow of length 3. So that's 1, 2, 3. There we are. So this is our y component of the vector. And notice that I'm taking 2 spaces here as 1, so that it's easy to separate things out and see them clearly. With this in place, we connect these two. There we are. And that is our vector v, which is purple, although I'm not sure you can see it very clearly, okay? But it's purple and it's got an x component of 2, the red one, and a y component of 3, which is light blue, okay? And now we're going to perform the following operation. We will take our vector and we will multiply it by the scalar 2. And let's understand geometrically what the effect is of this operation. So once again, let's construct a coordinate system so we don't clutter our picture. When you are doing this the first time, clarity matters. If you are doing this for the 58th time, clarity still matters. It always matters. Let's take a look. This is x. This is y. These are our axes. And now let's go through this process super slowly. Okay? We have our original vector v, which has a component of 2 and a 3, and then we are multiplying v by 2. So what this is telling us is the following. Okay? We are taking 2 as I'm showing you here. You will take your red x component and this component, and you will apply the distributive property to the purplish 2. Once you do this, you end up with the following. 2 times 2, so that gives this. You're distributing that inside, and then 2 times 3 gives this. Okay? So let's see. Let's make it a little red. Let's make the 3 here a little bluish. There we are. So it looks like this. Okay? So let us now remind ourselves that multiplication is repeated addition, which means the following. I will take my red component of the original vector, that is 2, and I will add it to itself twice. So that's a 1, that's a 2, that's a 3, and that's a 4. So the new component of the new vector that is double v is 4. Okay? So the x component of the new vector is 4 because it's double the original 2. Okay, so it looks like this. This big thick arrow here, okay? And the new y component is 2 times the original 3, which is of course 6. So let's label the axes here. 1, 2, 3, 4, 5, and 6. So we draw an arrow that is 6 long. That's 1, 2, 3, 4, 5, 6. Made that nice and thick so it's easy to see. Okay? This arrow is double that one. Just as this one here is double this one. Now that you have done these steps, you draw a new vector, connect with an arrow. It looks like this. So this new vector is double the previous vector in length. So let's simplify this. What we have is 4, 6. These are the components of the new vector that is double the previous one. Okay, so you would label this one as just v, but this big one here you would label as 2v. And the only way to do this is to apply the concept of the distributive property over here to the x component individually and to the y component individually. That's how it works. Okay, so this is in the case of a vector that's 2, 3. Now let's take a look at another example and grab some more paper here. All right. In this one, what we will do is look at a similar concept, but we'll make it negative 2v. Okay, so actually, because it's so dark, let me move that out. There we are. So now we'll take a look at negative 2v. So once again, let's begin with the following. Actually, I will do this in another video. So I think that's enough for this one. Thank you for watching.